All right, ladies and gentlemen, so what we're going to do today first is we're going to go over that summative you guys took last Friday through Sunday. So we're going to go over that one real quick. So I'm just going to go through the answer key, and I'm just going to point out some stuff that I saw that I just want to make sure we're aware of, make sure we're paying attention to. So the question, the statement of above says that Little Susie and the Purple Playground Rhinoceros just received a new air track for their toys. They have the air track set up with photo gates near each end and to measure the car's velocities. At each end, they have their cars with different masses. The Rhino's black truck has a mass of 625 grams, and Susie's pink convertible has a mass of 411 grams. The two of them push the cars towards each other, and the black truck passes through the photo gate with a velocity of 1.82 meters per second. The pink convertible passes through the photo gate with a velocity of 2.49 meters per second. The cars collide and bounce back through their respective photo gates. The black truck returns with a velocity of 1.58 meters per second, and the pink convertible returns with a velocity of 2.68 meters per second. So for this first question, what you're doing is you're drawing those pictures for before and after. I did like it. You guys, some of you guys are just great artists, which is wonderful. Some of you guys are more like me, where you drew some boxes, also fine. The big things is I wanted to see were that you're drawing the directions that these objects are going before and after the collision. So before they're going towards each other, after they're going away from each other. The other things that I was looking for was that you had the masses down, you had the velocities down. The one thing that you could or could not put here, it's up to you, is if you wanted to put that negative sign right here and the negative sign right here, or the negatives on the other guys. So if your negative was to the left or the negative was to the right, whichever way you put your negative, you didn't have to put them up in this part necessarily. But you did need to make sure that they came down here so that you have your negative direction and your positive direction. Because the first, beforehand, we have one car going in the positive direction and one car is going in the negative direction. So one of your momentums has to be negative at the beginning because they're going in opposite directions. So they're not both going to be positive values. So as we can see here, I used that going to the right was going to be positive, and my truck was going to the right. The convertible is going to the left, which is why my convertible's initial or before momentum is going to be that negative 1.02 versus my positive 1.14 kilograms per meters per second here. The other thing that you should have noticed was that our mass was grams up here, or grams in our paragraph to give us this information. So we did need to convert to kilograms. So it went from 625 grams to 0.625 kilograms into 0.411 kilograms. So we did need to make sure those are in kilograms, not just in grams here. Then afterwards, our momentum became negative for the truck and positive for the pink convertible because they went in opposite directions, and my negative was going to the left and my truck is now moving to the left. It is at negative velocity. Last but not least, our significant figures, each one of them should have 3, which is why we can see that each one of these has 3 significant figures. Any questions on 1 or 2? All right, number 3 is where we do our impulse. So we're finding the change in momentum. So to find the change in momentum, we have 2 options. We can find the difference in our velocities, so our final velocity minus our initial velocity, and multiply it by the mass, or we can take our final momentum and subtract it from our initial momentum. So I did the final minus the initial momentums. It does give you the same value. So you take your negative 0.988 kilogram meters per second minus your 1.14 kilogram meters per second to get a change in momentum of negative 2.13 kilogram meters per second. And so I took this final, the after minus the before, and then I did the same thing for my pink convertible and found out that my change in momentum there was 2.12 kilogram meters per second. I did see quite a few people when we're doing this part, which is where errors did come into place because we did the change in velocity and we were doing the change in velocity, but we forgot that direction again, or we were doing this change in velocity, but we did the beginning minus the end. That change in that delta, that triangle always means final minus initial, or after minus before. So we always need to make sure we're showing that. Question number 4, percent difference. So it says, what is the percent difference between the two total momenta? So the momentum before the collision and the total momentum after the collision. So I took my black truck's momentum before the collision and added to it the initial, the before momentum of the pink convertible, and found out that the total momentum before was 0.12 kilogram meters per second. Did the same thing with my after and found out that my total after was 0.11 kilogram meters per second. And these all have two significant figures because remember, addition and subtraction, we just look at the smallest decimal place value. Once I did that, what I did next was made sure that I did my percent difference equation. So I found my before minus my after divided by the average. So my before plus my after divided by 2. So when I plugged in my numbers, make sure that you're doing this part together, because that divided by 2 only goes to the addition. It doesn't go to the whole thing. I did see some issues with that. So just make sure when we do our percent difference, it's always the addition divided by 2, and then we do the subtraction divided by that addition. Once you found your percent difference, you found it to be 8.7% because there's 2 sig figs here. Other percents that I was okay with you getting were 6.9%. And that would have been if you left the 0.112 here. So 6.9 if you left that there. If you did not round these to 3 decimal points here, if you brought in that 4th decimal point, you also could have gotten 1.2%. It just depends on when you round it and where you leave the decimal points. So all 3 of those percents were accepted there. And then last but not least, question 5 was your explanation. So it says, explain how this experiment confirms some of the laws we've covered in class so far, such as the law of conservation of momentum and Newton's 3rd law. Use 1 paragraph for each law and defend your explanation with the calculations from above and be specific on how they support those laws. So law of conservation of momentum, there's a couple ways we could have gone about this. We could have talked about the before and after and the percent difference and the fact that these values are super close to one another and our percent difference is very small, which means that our momentum before and after are almost the exact same, meaning that there was little to no momentum loss throughout this collision, meaning that there is a total conservation of momentum, or that the momentum before is equal to the momentum after. You could also have brought up the impulse or the change in momentum. I was also okay with that. And the fact that those are very small, which means that the momentum should be about the same because the change in these momentums were very similar. As far as that Newton's 3rd law and that every force has an equal and opposite force, or every action has an equal and opposite reaction, this is where we could have brought up our velocities in the fact, or our momentums in general. So that first part, where our velocity beforehand was going in the positive direction, and because of that collision, our velocity was going backwards in the negative direction afterwards. And the velocity of the truck got smaller, but the velocity of the convertible got larger, showing that the overall change was the same. Are there any questions on any of those 5 problems? All right, so then today what we are doing is not that. What we're doing is we are going to be working on our relearn, retest stuff. So in order to do that, so you can click in multiple spots. I'm just going to click here to show you. All your Unit 3 stuff is right there. In order to retake the test or to take the retake, you need to have all of your assignments done. So as you can see, the POGL for Momentum, homework 1, the Yeti Sled Wars gizmo, homework 2, the Air Track gizmo, and the relearn. So there are 6 assignments you have to have turned in before you can take the retest or the retake. If you have the first 5 of them turned in, that means all you have left to work on is that relearn before you can retake your test. If you don't have any of them turned in, you have a little bit more work to catch up on before you can retake that test. Reminder that the retake does not close. So that's just open for you. It'll be there. It doesn't change. It'll still be there later on next week, whenever you get to it. But the longer you wait, the more difficult it's probably going to be for you, because it means that you had a longer time to forget some of the information, maybe that nitty gritty little details, which means you might forget a little bit more and might not do as well as you would hope. So make sure if you are trying to do it, I would recommend you're trying to do it sooner rather than